Welcome back to Math 104. Now we're going to apply the binomial probability model to an important topic, which is understanding the accuracy of surveys. Suppose that a law has been proposed that requires everyone to eat broccoli, because it's good for everyone's health, and that's a good thing. When a law is proposed and people find out about it, there's discussion of it, there is some percentage of the public in support of this law. But you don't know what it is yet. Your goal is to find out what that percentage is. Your goal is to find out what percentage of the public does support the law by conducting a survey. If you survey 10 people and ask them the yes or no question, do you support this law, you will receive a certain number of yeses, and the number of yes answers you receive will be some number between 0 and 10. Now, when you ask people this question, they might not hear it as a yes or no question. They might spend 10 minutes telling you stories about their experiences with broccoli without actually saying yes or no to your question, but we're going to approach this as counting just how many yeses you heard. So every person you ask either gives you an unambiguous yes, or they don't give you an unambiguous yes, and you're counting the number of yes answers. Why 10 people? That's just an example for right now. We could survey 1,000 people, or maybe even 10,000 people. We'd like to find out information about the entire public and its level of support for the law, but in practice, we will only be able to survey a relatively small number of people. If you receive 3 yes answers in a survey of 10 people, that is to say that 30% of your sample supports the law, the conclusion will be that 30% of the public supports the law, because you're only asking 10 people. That is all the information you have to work with to draw a conclusion about the entire public. Based on 3 yes answers out of 10 people, you would conclude that 30% of the public supports the law. This statement about the public at large might or might not be correct, but it is your best estimate based on the survey results. If you receive 6 yes answers in your survey of 10 people, that means that 60% of your sample supports the law. The conclusion of your survey will then be that 60% of the public supports the law. The purpose of the next few questions is to examine how likely it is for a survey to reach the correct conclusion, or a nearly correct conclusion, about how much public support for the law there really is. Suppose, just for example, that in fact 40% of the public actually supports the law requiring everyone to eat broccoli. But you, as a pollster, as someone who takes surveys, don't know this yet. We're just assuming this is the reality, 40% public support. This means that if you receive 4 yes answers in your survey of 10 people, so 40% of your sample supports the law, the conclusion of your survey will be that 40% of the public supports the law, and that will be exactly correct. If the 10 people you ask are perfectly representative of the public at large, great. Then your survey will reach the correct conclusion. If instead, the 10 people you ask are not perfectly representative of the public, maybe you receive only 3 yes answers, or maybe you receive 5 yes answers, then your unrepresentative sample will lead you to draw a somewhat incorrect conclusion. If you receive 2 yes answers or 6 answers, your results will be even more incorrect. And if you receive 10 yes answers, if the 10 people you happen to ask are dedicatedly pro-broccoli people, then you will conclude that the entire public supports the law. But that will be outrageously incorrect because the 10 people you asked happen to be such an unrepresentative group. The statement that 40% of the public actually supports the law, we will interpret to mean that if several people are surveyed, each individual has a 0.4 probability of supporting the law, independently of other people's views on the subject. In other words, each person's answer to the survey question is a Bernoulli trial. Each individual person is their own Bernoulli trial, with little p the probability of supporting the law equal to 0.4. It's useful here to look at a histogram for this experiment. If we survey 10 people, and each one has a 0.4 probability of saying yes, that is mathematically equivalent to flipping a coin 10 times. Where the coin is biased, it has only a 0.4 probability of heads, and a 0.6 probability of tails. If you draw the histogram for that experiment of flipping 10 coins, or asking 10 people their opinion about this law, where little p equals 0.4 instead of 0.5, you'll notice that it still has this roughly bell-shaped appearance, but now the tallest rectangle sits above 4. The event that 4 people say yes is more likely than the event that 3 people say yes, and it's also more likely than the event that 5 people say yes. It is very unlikely that 10 people say yes, It's also unlikely that 0 people say yes, but you'll notice that the whole picture here is shifted a little bit to the left. There is an asymmetry here. Let's find the probability that a sample of 10 people is exactly representative of the population on the issue of the broccoli mandate. That is, the poll, the survey, predicts completely accurately that 40% of the population supports the law. Let's first just interpret the language here. This is saying that when we ask 10 people, the result is right on. The result is what we are really asking for is the probability that 4 people What we are really asking for is the probability of 4 yeses in 10 trials. I'm writing Y for yes. So the probability of 4 yeses in 10 trials, this is a job for the binomial probability model. This equals 10 choose 4 times 0.4 raised to the 4th power. This is the probability of yes raised to the power of how many yeses there are times 0.6 raised to the 6th power. This is the probability of something other than a yes raised to how many of those occur. And this turns out to be approximately 0.2508, which, by the way, is already indicated here. The combined area, the total area inside all the rectangles in this histogram, equals a certain amount. And the highlighted rectangle that corresponds to exactly 4 out of 10 people saying yes, that rectangle has a certain area. It occupies a certain percentage of the total area of the histogram. That percentage is 25.08%. So that's how likely it is, if we ask 10 people, that the result will be 4 yeses, and if we do get that result, that's good news. That means that we will draw the correct conclusion that 40% of the population supports the law. That would be great to have a survey result that's completely accurate, but no one who works in the survey business expects results to be exactly correct. There is always some margin of error. Recognizing this notion of margin of error, let's now find the probability that a sample of 10 people is accurate with a margin of error of plus or minus 10%. In other words, according to the poll, according to the results of our survey, the percentage of population in favor of the law is somewhere between 30% and 50%, or in terms of the histogram that it looks like so. The truth of the matter is that 40% of the public supports the law, but maybe we get a slightly unrepresentative sample when we ask 10 people. Maybe we get only 3 yeses, maybe we get 5 yeses. That would be a somewhat unrepresentative sample, but not terribly so. So how would we compute that probability? We can see here already what the answer is, but let's make sure we understand how to compute it. This is the probability of 3 or 4 or 5 yeses in 10 trials. Again, a job for the binomial probability model. Now we're computing the sum of 10 choose 3, 0.4 raised to the 3rd power times 0.6 raised to the 7th power. Notice, the experiment is what the experiment is. It is still true that each person we ask really does have a 0.4 probability of saying yes. We're still flipping a coin with a 0.4 probability of heads. So the probability of 3 yeses still involves 0.4 to the something and 0.6 to the something, but it's 0.4 to the 3rd times 0.6 to the 7th. Plus, the thing we computed earlier, 10 choose 4, times 0.4 to the 4th times 0.6 to the 6th, plus the likelihood of exactly 5 people saying yes when we ask their opinion, 10 choose 5 times 0.4 to the 5 times 0.6 to the 5. The exponents always have to add up to 10 because we're asking 10 people, or we're flipping a coin 10 times. This turns out to be approximately 0.6665. That is a much higher probability than if we were holding out for perfect accuracy. But still, that's not such a high probability either. This is only about a 2/3 chance that the result of our survey will be somewhere reasonably close to the truth. Now let's study the effect of sampling 20 people instead of 10. Let's find the probability that a sample of 20 people is exactly representative of the population on the issue of the broccoli mandate. In other words, that the poll predicts completely accurately that 40% of the population supports the law. Here now is the histogram for the 20-person version of this experiment. So what is the probability that the sample of 20 people we take really is exactly representative of the population? That would require us to get exactly 8 yeses from the 20 people we ask. 8 yeses in 20 trials. The binomial probability model tells us to compute 20 choose 8 times 0.4 to the 8, 0.6 to the 12. Right? These exponents now have to add up to 20 because that's the number of trials. This is approximately equal to 0.1797, a little under 18%. So this is less than what we found when we were sampling 10 people. It is harder to get a perfectly representative sample when you ask more people, and that agrees with things that we have found earlier in the course about the likelihood of getting exactly half heads, half tails when you flip a coin a certain number of times. That agrees with what we found earlier in the course about the probability of getting exactly half heads, exactly half tails when you flip a fair coin a certain number of times. Before going on to the next video, find the probability that a sample of 20 people is accurate with a margin of error of plus or minus 10%. This means that according to the poll results, the percentage of population in favor of this law is between 30% and 50% inclusive. So you see here what the answer is going to be, but set it up and do the computation yourself to make sure you're getting it right.